Good morning to all. So, in the previous lecture, we have discussed about the sources of energy and about the conventional sources of energy, the definition of the conventional energy, and the types and the sources which include in the conventional sources like the coal, petroleum, and the natural gases, such type of the sources, and the definition and the types of the coal, natural gases, refine and the needs of the refinement of the petrol. So and the last we have discussed about the advantage and disadvantage of the conventional sources. So in this lecture we will discuss about the renewable energy sources. So we all know about the conventional sources, which is finite in the nature and which is not last forever. So in the definition of renewable energy, you can say you can say that which is unlimited in the nature, which is abundant form in the nature, but which is discontinuous energy sources. So renewable energy is natural energy which does not have a limited supply, which does not have a limited supply. That means which is abundant form in the nature, which is not limited in the nature, which is not finite in the nature, which is infinite in the nature. So renewable energy can be used again and again and will never run out. So the second second bullet point said that the renewable energy is energy which comes from natural resources such as sunlight, wind, rain, tides, and geothermal heats, which are renewable, naturally replenished. Okay, so this is the definition. This is the vast definition and the most important definition of the renewable energy sources. That which comes from the renewable energy is the energy which comes from the natural resources, and the natural resources include the sunlight, the wind, rain, tides, and geothermal heats, and etc. So, which are renewable, which can be renewed, which may be renewed and the naturally replenished. So, renewable energy is an alternative to fossil fuel. And the which sources and which fuels are the fossil fuels, like the petroleum, like the coal, and the natural gases. Such type of the fuels is in the category of the fossil fuels, and the nuclear power. So renewable energy is interrelated to the fossil fuels and the nuclear power, and was commonly called alternative energy sources. And it's also called the alternative energy sources because it can be used widely during this time and such time. In the European Union, in the case of the Germany, you can see the Germany stored the future energy. Germany stored the 10 years future energy and within the form of the battery and within the form of the other technologies. And the generation of the PV array and the PV cells is mm, is is in the wide amount in the it is in Germany or in the European countries. So the list of the renewable energy sources. So there are certain sources which are listed in the category of the renewable energy, and which are the biomass, hydro, geothermal, solar, tidal, wave, wind, and wood. So biomass contains the you can see in the next slide says that the biomass is contains the plant material, such plant material, and the plant material used to generate energy. It can and you can say the biomass is an renewable energy sources because the energy it is contains from the sun. So we are seeing the list of the renewable energy sources: the biomass, hydel, geothermal, solar, tidal, wave, wind, and wood. The renewable energy replaces the conventional fuels in four distinct areas. We already discussed about that the renewable energy is in the abundant form in nature, and it can replace the conventional fuel in the four distinct area, like the power generation, like the hot water and the space heating area, like the transport fuels, and the rural energy services. You can say the off grid. You can say the off grid. So first of all, we will discuss about the wind energy. What is the wind energy, and what is requirement for this, and the site selection for this. So wind power, the airflow. Airflow can be used to run the wind turbine. You can say the air current. Air current, airflow is the same thing. The airflow can be used to run the wind turbine. So modern wind turbine ranges from around 600 kilowatt to 5 megawatt of rated power. Although the turbine with rated output of 1.5 to 3 megawatt have become the most common for commercial use. So the power output of a turbine is a function of cube of wind speed. So as the wind speed increases, the power output also increases dramatically. So you can say there is a relation between the power output and the wind speed. And this relation is a function of cube of the wind speed. You can say if the power output is denoted by the P and the wind speed is denoted by the Ws, then the P equals to Ws cube. You can say the P equals to Ws cube. So the wind energy. So what is the main requirement to set up the wind plant? To wind plant. So the main requirement is the to set up the wind plant is the area, and the altitude of the sites, and you can say site selection for the wind energy. तो आपको ऐसा साइट सेलेक्ट करना है जहाँ पे विंड एनर्जी सक्सेसफुल हो सके. For example, you can see the wind energy साउथ इंडिया के अंदर देखा होगा, और गुजरात और वेस्टर्न राजस्थान के अंदर विंड एनर्जी का बहुत सारा स्कोप देखा होगा आपने. ठीक है. तो एक्चुअली क्या है कि जो वेदर कंडीशंस हैं, जियोग्राफिकल कंडीशंस हैं, देर आर जियोग्राफिकल सर्वे फॉर द सेम, एंड देर फॉर द वेदर सर्वे फॉर द सेम, और द साइट सिलेक्शन, द एरिया. तो एरिया देखा जाता है, वेदर कंडीशन देखी जाती है उसके लिए, और एक ये भी देखा जाता है कि जो विंड स्पीड है वो कंटिन्यूस है या नहीं है. द विंड स्पीड शुड बी कंटिन्यूस इन दैट एरिया, or the moderate, not so fast, not so slow, and moderate speed should be there. So area where the wind are stronger and more constant, so wind speed should be more constant and more stronger, such as the offshore and the high altitude sites are preferred locations for the wind farm. So the typical capacity factor are 20 to 40% with values at the upper end of the range in particularly favorable sites. तो एक सबसे अच्छा एग्जांपल मैं जैसे बताता हूँ कि सोलर का हम लोग देखते हैं कि सोलर वेस्टर्न राजस्थान के अंदर सबसे ज़्यादा सक्सेसफुल है, वेस्टर्न राजस्थान एंड द वेस्टर्न गुजरात. If we located the solar power plant at the northeast India, so is it successful or not? The successful rate is minimum. I think the successful rate is minimum because it not support the weather condition, it not support the sun condition, then the solar physics, it not match with the solar physics. Okay. So this is the main tower of wind energy. The number one, the one number shows the blades, and the minimum and the maximum. Minimum probability of the blade is 1, and the maximum probability of blade should be the 3 and 4. So the first denoted the blade, and the second denoted there is the rotor, which rotate the generator, and the blades are connected with the rotor turbine. You can see the rotor, and the rotor is coupled with the generator. When the air current or the airflow strike from the blades, then the blade rotates, and as well as the rotor rotates. You can say the rotor rotates, and the rotor rotates, which is also coupled to the generator the shaft. Then generator is also rotate, and generator rotates, which follows the Faraday law of electromagnetic induction. and makes an electricity at the output side. So there is a simple principle. If you can say, if you see it very easy way, that when the air flow or air strike at the blade, then blade moves and blade rotate, and the rotor which is connected with the blade is also rotate, and the rotor is also coupled to the gearbox, and the generator shaft. You can say the generator shaft, and the generator shaft is also rotate. Then generate when the generator rotate, there is a EMF induction in the generator, and the electricity generation at the output side, and you get the electrical power at the output. So the number 3 shows the pitch, which pitch is control for the blade and the direction, blade direction, and the speed of the speed of the gearbox, and the speed of the as well as the speed of the generator shaft. So by using the pitch, you can controlling the speed of the generator. And 4 is the brake, which is used to brake the generator at an instant. And fifth point shows the low speed shaft. Fifth point shows the low speed shaft, which is connected to the gear, and this gear is connected to the other gear, which is imposed on a generator shaft. And the sixth point, it shows the gearbox, and the gearbox is also controlling for the speed of the generator. You can say that it's a part of speed controlling, generator is speed controlling. And the number 7 shows the generator, and number 8, controller is used for to control the overall the mechanism, and the wind the electricity generation mechanism. And the 9 number shows the anemometer, and the anemometer shows the speed of the wind, and which indicate the which speed at that any instant, and the airflow, the air current speeds at any instant. Number 10 shows the wind fan, and number 11 is the nacelles, and nacelles is the output side, which is connected to the output side of the generator. And number 12 is the high speed shaft, so the number 5 shows the low speed shaft, and the number 12 is shows the high speed shaft. Number 13 is the yaw drive, and the yaw drive number 14 is show the yaw drive. Yaw drive is also for the controlling mechanism, and the yaw motor, which is connected to the yaw drive, which control the yaw drive. The yaw drive control the yaw motor. And the number 15 is the tower. The tower, which contain the all of the apparatus, all of the devices in it. So there is a pictorial view of wind energy setup, and then you can say the wind energy tower, and you can say the component of the wind energy generation. So the wind energy. We more discuss about the wind energy. Globally, the long-term technical potential of wind energy is believed to be the 5 times total current global energy production, or the 40 times current electricity demand. This could require wind turbine to be installed over large areas, particularly in area of higher wind resources. Offshore resources experience mean wind speed of approximately about 90% faster than that of the land. So offshore resources could contribute substantially more energy. So wind energy is now in the trend, but wind and so on, but it is always used as a peak load plant, and it is always used with the coordination with the solar or other DC sets or something, some other electricity generation sources. So the second point, about the second point, that the second sources is the hydropower sources. The hydropower sources, that means it also called the hydel. In the short, it is also called the water is called the hydropower. The energy from the water is also from the hydropower, and that energy can be harnessed and used. So since water is about the 800 times denser than air, so in the case of the wind power plant, in the case of the wind energy, the wind is used as a fuel, and wind is used to generate the electricity. But in the case of the hydropower, the water is used for the generation of the electricity or rotate the turbine blades. Rotate the turbine blades. So if we compare the density of the air and water, then the water is 800 times denser than the air. Even a slow flowing stream of water or a moderate sea swell can yield a considerable amount of energy. So there are many forms of water energy. So micro hydro systems and the damless system also here. So micro hydro systems are hydroelectric power installation that generate electricity from small power supply. So damless hydro system derive the kinetic energy from rivers and ocean without using a dam. So there is no dam in the damless hydro system. We can use only the wave energy or the ocean energies directly to generate the electricity. So the ocean energy is also the part of the damless hydro system. You can say the tidal energy is also the ocean energy, sea energy, and the tidal energy is also the part of the damless hydro system, where there is a no dam or there is no accumulation of the water at the particular state. So the ocean energy describes technologies to harness energy from the ocean and the sea. So this include marine current power, ocean thermal energy conversion, and tidal power. So this is the pictorial view of the hydroelectric power generation. You can see here there is a reservoir and this is a slice gate which percolate the water through the penstock to the turbine blades, and this is the penstock which carry the water from reservoir to the turbine blades at a given pressure. This is the dam. This is a dam, and the when water comes from the reservoir through the penstock and strike the turbine blades. There is a horizontal generator is connected at the horizontal manner, and this is the powerhouse. This water rotate the blades and rotate the shaft, and shaft is coupled to the generator shaft, and the generator is also rotate, and finally at the output side we get power. So there is a transformer at the output side which step up the power and for the transmission purpose. So the power in the if we're talking about the thermal energy and any types of the energy, so the the power is generated from the initial condition is 11 kilowatts, only 11 kilowatt. So the power is step up by using the transformer. This energy is step up by the transformer, and then further it will be transmitted through the power transmission cable. So this water, after the striking the turbine blades, this water is downstream outlet, which is used for the civil purpose, for the crop for the crop purpose and for the drinking purpose at the village. So this is the practical diagram of the dam. You can see the water is accumulated here, and this is called reservoir or the dam. And these are the gates of the dam. In the rainy season, mm, they often to be used to empty the reservoir at the level. And this is the powerhouse where the whole process is carried out to generation. So in this lecture, we have discussed about the renewable energy sources and basic types of the renewable energy sources is listed in this lecture, and we have discussed about the wind energy and mainly the hydropower energy in this lecture. If you have any query regarding the both, you can call me, you can WhatsApp me, and you can ask me in this lecture if you want. So thank you very much. Thank you. Now I am stop presenting my screen, and thank you to being with me and with for your patience. Thank you very much.